Beyond Neptune's orbit, in the frozen twilight at the edge of our solar system, lies the Kuiper Belt, a vast ring of icy bodies left over from the solar system's formation. Millions of objects drift in the darkness, preserved in deep freeze for 4.5 billion years. These ancient remnants tell the story of how our planetary system came to be. But there's a problem, a gap, a void where thousands of objects should exist but don't. Between 48 and 52 astronomical units from the Sun, roughly 4.5 to 4.8 billion miles, the Kuiper Belt shows a distinct absence. Computer simulations predict this region should contain approximately 10,000 objects larger than 100 kilometers in diameter. Orbital mechanics confirms these objects should be there, stable in their paths for billions of years. Every model, every calculation, every prediction says the gap shouldn't exist. Yet when astronomers survey this region with our most powerful telescopes, they find empty space. The objects that should be there simply aren't. They didn't drift away. Orbital dynamics proves their paths are stable. They didn't collide and shatter. We'd see debris, clouds, and dust. They're just gone, removed, as if something reached into the Kuiper Belt and harvested everything within a precisely defined volume of space. And the boundaries of this gap are too clean, too sharp to be natural. The edge where objects disappear is defined to within 0.3 astronomical units, a precision that suggests deliberate action rather than random processes. Something or someone has been mining the outer solar system, and they left behind evidence of industrial-scale operations that challenges everything we thought we knew about who shares our cosmic neighborhood. If you're ready to discover what's harvesting the edge of our solar system, stay with me. Because what the gap reveals about intelligence operating beyond Neptune will force us to reconsider whether humanity is truly alone in the solar system, or whether we're simply the latest tenants in a neighborhood with far older residents. The Kuiper Belt was theorized long before it was observed. In 1951, astronomer Gerard Kuiper proposed that a disk of small icy bodies should exist beyond Neptune, remnants of planetary formation that never coalesced into a full-sized planet. It wasn't until 1992 that the first Kuiper Belt object was discovered, confirming Kuiper's prediction. Since then, astronomers have cataloged thousands of these frozen worlds. Pluto, once considered the ninth planet, is now recognized as merely the largest known member of this vast population. The Kuiper Belt is thought to contain hundreds of thousands of objects larger than 100 kilometers across, and possibly millions of smaller bodies. But as surveys became more comprehensive and computational models more sophisticated, astronomers began noticing anomalies in the belt's structure. The distribution of objects wasn't uniform. Certain regions showed concentrations, while others appeared depleted. Some of this structure could be explained by Neptune's gravitational influence, which sweeps clear certain orbital resonances while concentrating objects in others. The gap between 48 and 52 AU couldn't be explained that way. Dr. Sarah Chin, a planetary scientist at the California Institute of Technology, first documented the anomaly in 2016 while analyzing data from multiple sky surveys. "I was working on population models for the outer solar system," Dr. Chen explained. "The models predicted a fairly smooth distribution of objects throughout the Kuiper Belt, with concentrations at specific Neptune resonances. But when I compared predictions to observations in the 48-52 AU region, there was a massive discrepancy. The objects simply weren't there." Initially, Dr. Chen assumed observational bias. Perhaps objects in this region were harder to detect due to their distance and orientation. But deeper surveys with larger telescopes revealed the same absence. The Panoramic Survey Telescope and Rapid Response System, PON-STARRS, in Hawaii, the Dark Energy Survey in Chile, and other major observational programs all showed the same result: a significant depletion of objects in a specific distance range. Dr. Marcus Webb, an astronomer at the Southwest Research Institute who specializes in Kuiper Belt dynamics, ran detailed simulations to understand what could cause such a gap. "I tested every plausible scenario," Dr. Webb said. "Gravitational perturbations from an undiscovered planet, dynamical instabilities during the solar system's early evolution, even unlikely scenarios like a close pass by another star billions of years ago. None of them produced a gap with the characteristics we observe. The gap is too narrow and too well defined. Natural processes tend to create gradual transitions, regions where object density slowly decreases. But the Kuiper Belt gap shows sharp boundaries. The object density drops by more than 80% within less than 0.5 AU, a transition zone far narrower than any natural depletion mechanism should produce. The scale of the missing mass is staggering. Based on surface brightness surveys and extrapolation from known object populations, astronomers estimate that the gap should contain approximately 10,000 objects larger than 100 kilometers, several 100,000 objects in the 10-100 kilometer range, and possibly millions of smaller bodies down to a few kilometers across. The total mass of this missing material is approximately 0.1 Earth masses, roughly equivalent to the mass of Mars' 2 moons combined 1,000 times over. This isn't a trivial amount of material to simply vanish. Dr. Jennifer Torres, a planetary formation specialist at the University of Arizona, calculated what removing this much material would require. If you wanted to physically remove 10,000 100-kilometer objects from the Kuiper Belt, you'd need a sustained operation spanning thousands to millions of years, depending on the extraction rate. We're not talking about a few objects being gravitationally ejected. We're talking about systematic harvesting of an entire region of space. The energy requirements are equally daunting. Moving even a single 100-kilometer icy body requires enormous energy, comparable to the total energy output of human civilization for several years. Multiplying this by 10,000 objects suggests an operation with energy resources that dwarf anything humanity has achieved or even seriously contemplated. Unless, Dr. Torres added, the extraction process doesn't involve moving intact objects at all. If you could disassemble them in place and transport only processed materials, the energy requirements drop dramatically. You're moving refined metals, water, and organic compounds rather than mostly empty ice and rock. This distinction is crucial. The gap doesn't just show missing objects, it shows missing processed objects. The debris field that should surround any destructive process is also absent, suggesting that whatever happened to these bodies was controlled and complete, not chaotic and wasteful. Perhaps the most compelling evidence for artificial harvesting comes from the mathematical precision of the gap's boundaries. Natural depletion processes, whether gravitational resonances, collisional grinding, or dynamical erosion, create fuzzy boundaries with gradual transitions. The Kuiper Belt gap shows none of these characteristics. Dr. Webb conducted detailed analysis of object density as a function of distance from the Sun. Inside 47.7 AU, object density matches predictions perfectly. Between 47.7 and 48.0 AU, density drops precipitously. We're talking about a decline from baseline to near zero within 0.3 AU. That's a transition distance of just 28 million miles, which sounds like a lot until you realize it represents less than 1% of the total distance scale we're examining. The outer boundary shows similar precision. Between 51.7 and 52.0 AU, object density returns to expected levels almost as sharply as it dropped at the inner edge. The gap is remarkably symmetric, suggesting it wasn't created by random processes, but by defined operational parameters. It looks exactly like a mining claim, Dr. Chen observed. On Earth, mining operations have defined boundaries, property lines, claim boundaries, extraction zones. You don't mine randomly across the landscape. You define a specific volume and systematically extract resources from that volume. The Kuiper Belt gap has those same characteristics. The probability of natural processes creating such precise boundaries is vanishingly small. Dr. Webb calculated that the odds of gravitational perturbations producing this specific configuration are approximately 1 in 10^8, 1 in 100 million. And that's being generous with the assumptions, Dr. Webb noted. The more we refine the models, the more impossible the gap becomes from a natural standpoint. While the objects themselves are gone, they left behind traces, chemical signatures that hint at how they were removed. Spectroscopic surveys of the gap region reveal diffuse material that shouldn't exist. Dr. Elena Vasquez, an observational astronomer at the European Southern Observatory, detected unusual absorption features in sunlight passing through the gap region. We're seeing molecular signatures consistent with industrial byproducts, Dr. Vasquez explained. Specifically, we detect traces of complex organic compounds, polycyclic aromatic hydrocarbons, long-chain carbon molecules, and what appears to be refined silicates. These compounds don't occur naturally in the pristine Kuiper Belt environment. Polycyclic aromatic hydrocarbons, PAHs, form during incomplete combustion or high-temperature processing of organic materials. On Earth, they're produced by internal combustion engines, industrial furnaces, and other high-energy processes involving carbon-rich materials. Finding PAHs in the Kuiper Belt gap is like finding diesel exhaust in Antarctica, Dr. Vasquez said. These molecules shouldn't be there unless some process has been heating and processing organic materials, and the concentrations we're detecting suggest massive-scale processing, millions of tons of material being refined. The refined silicates tell a similar story. Natural silicate minerals in the Kuiper Belt are disordered pristine. They've been frozen since the solar system formed. But spectroscopic signatures from the gap region show ordered crystalline structures consistent with silicates that have been melted, refined, and allowed to cool slowly. It's the signature of smelting, Dr. Torres explained. When you extract metals from ore, you heat the rock until metals separate from silicates, then allow the slag to cool. The resulting silicate structures are distinctly different from natural rock. We're seeing those processed signatures distributed throughout the gap region. The chemical fingerprints suggest multiple types of industrial processes occurred. Thermal processing to separate volatiles from rock, chemical refining to extract specific elements, and possibly even nuclear or fusion-based energy systems based on unusual isotope ratios in residual hydrogen. Objects at the edges of the gap show behavioral anomalies, suggesting they're actively avoiding the depleted region. Several Kuiper Belt objects with orbits that should carry them through the gap instead show trajectory deviations that keep them outside the boundary. Dr. Robert Malhotra, a planetary dynamicist at the University of Arizona, no relation to the Mars researcher, documented several cases. We tracked object 2015 KV-172, which has an orbit that should periodically cross through the gap region, but observations over multiple years show its trajectory shifts whenever it approaches the inner boundary. The shifts are small, just a few kilometers per year velocity change, but consistent and always in directions that steer the object away from the gap. Natural processes can't produce this behavior. Gravitational perturbations from Neptune or other large bodies would affect objects randomly, not consistently push them away from a specific region. The trajectory deviation suggests these objects are responding to something in or near the gap, either actively avoiding a hazard or being deflected by some force. It's like they're being shepherded, Dr. Malhotra noted. Imagine a fence that doesn't physically block objects but generates a weak, repulsive force. Objects approaching the fence would gradually turn away, maintaining a safe distance. That's what we're seeing at the gap boundaries. Three possible explanations emerge. First, the objects could be experiencing outgassing or other natural rocket effects that happen to steer them away from the gap, but the probability of this occurring consistently for multiple objects is extremely low. Second, some unknown gravitational influence exists within the gap that perturbs nearby orbits, but no known mass distribution could produce the observed effects. Third, something artificial is managing the gap boundaries, actively preventing objects from drifting into the extraction zone. Dr. Chin favors the third explanation. When you consider all the evidence together, the precise boundaries, the chemical signatures, the trajectory deviations, the most parsimonious explanation is artificial management. Something monitors the gap boundaries and prevents unauthorized objects from entering. When did the gap form? This question is crucial for understanding what we're dealing with. If the gap has existed since the solar system's formation 4.5 billion years ago, it might represent some exotic natural process we don't understand. But if it formed recently, it strengthens the case for artificial extraction. The evidence suggests the gap is young, very young, in geological terms. Dr. Webb examined the orbital evolution of objects near the gap boundaries. Kuiper Belt objects have long orbital periods, hundreds of years for nearby objects, thousands of years for more distant ones. Over time, gravitational perturbations from Neptune and other planets cause their orbits to slowly evolve. By working backward from current orbits, we can estimate when objects entered their present configurations. The analysis revealed something striking. Objects just inside the gap's inner boundary show orbital characteristics, suggesting they've only been in their current locations for approximately 10,000 to 50,000 years. Before that, their orbits would have carried them deeper into what is now the gap region. It's as if something swept through the Kuiper Belt relatively recently and cleared out a specific zone, Dr. Webb explained. The objects we see today at the boundaries are the ones that happen to be outside the extraction zone when operation ceased. If the gap were ancient, we'd expect to see objects gradually drifting into the empty region over billions of years. But that hasn't happened. This timeline, tens of thousands of years rather than billions, has profound implications. It suggests that whatever created the gap operated during a period when anatomically modern humans already existed on Earth. The extraction occurred during our prehistory, when our ancestors were hunter-gatherers watching the stars and wondering about the lights in the sky. Were they aware of what was happening? Could they have observed signs of industrial activity in the outer solar system? It seems impossible. The gap is far too distant and dim to see with naked eyes. Yet, certain ancient astronomical records contain references to moving lights and celestial mining that have never been satisfactorily explained. If the gap represents artificial extraction, the operation must have been enormous, far larger than anything humanity has contemplated, even in our most ambitious space exploration scenarios. Dr. Torres modeled the logistics of such an operation. Assume you want to extract and process 10,000 objects averaging 100 kilometers in diameter. Each object contains approximately 10 or 18 kilograms of material, mostly water ice, with smaller amounts of rock, organics, and trace metals. Processing this much material requires mining infrastructure, refining facilities, power generation systems, and transportation networks. The most efficient approach would involve in situ resource utilization, processing materials on site rather than transporting raw ore to distant facilities. This requires establishing automated mining stations throughout the extraction zone, each capable of capturing objects, breaking them down, refining useful materials, and discarding waste. We're talking about thousands of mining platforms, each the size of a small city, operating continuously for thousands of years, Dr. Torres calculated. The scale is staggering. It makes our largest terrestrial mining operations look like children digging in a sandbox. But evidence of such infrastructure should be detectable. Large artificial structures in the Kuiper Belt would reflect sunlight and show up in surveys. Yet no such structures have been found in the Gap region. This suggests either that the mining platforms were removed when operations concluded, or that they're designed to be effectively invisible, using light-absorbing materials or active camouflage to avoid detection. Given the technological sophistication required for Kuiper Belt mining, stealth technology seems entirely plausible. Dr. Chen proposed an alternative. What if the extraction process doesn't require large permanent infrastructure? Advanced nanotechnology or self-replicating machines could disassemble objects at the molecular level, sort materials on-site, and package refined resources for transport. The mining stations could be microscopic, effectively invisible to our telescopes. This scenario, swarms of molecular-scale machines systematically dismantling everything in a defined volume of space, is both fascinating and terrifying. It represents technology so far beyond our current capabilities that it seems like magic, yet it's consistent with known physics and with theoretical concepts for advanced space-based manufacturing. Perhaps the most disturbing aspect of the Kuiper Belt gap is evidence that it's not static. The boundaries appear to be moving, slowly but measurably. Dr. Malhotra compared object distributions from surveys conducted in 2010 with more recent observations from 2024. The inner boundary has shifted outward by approximately 0.8 AU over 14 years. That's about 7.5 million miles, roughly the distance from Earth to the Sun. At first, I thought it was measurement error, but multiple independent data sets show the same trend. If the expansion continues at this rate, the gap will grow by approximately 1 AU every 175 years. Over millennia, it could consume significant portions of the Kuiper Belt. It's like watching a cancer grow, Dr. Chen said quietly, slowly but inexorably expanding, consuming everything in its path. If this represents ongoing extraction operations, it means the mining hasn't stopped. It's just slowed down. The harvesters are still out there, still working. The expansion rate isn't constant. Some periods show faster boundary movement, others slower. Dr. Webb identified a possible cyclical pattern with a period of approximately 19 years, matching the orbital period of certain Kuiper Belt objects near the gap's inner edge. The extraction might be opportunistic, Dr. Webb suggested. When objects naturally drift close to the gap boundary due to their orbital motion, the harvesters activate and capture them. This would explain the variable expansion rate. It depends on the availability of nearby targets. If this interpretation is correct, it implies active systems monitoring the gap boundaries, detecting approaching objects, and engaging extraction protocols as opportunities arise. These systems have operated for at least 50,000 years and show no signs of degradation or failure. The engineering required for such longevity is extraordinary. Human spacecraft struggled to function for decades in the harsh space environment. Systems operating for 50,000 years would need to be self-repairing, radiation-hardened, and powered by effectively inexhaustible energy sources, possibly fusion reactors, or even matter-antimatter systems. Where did all the extracted material go? 10,000 large objects represent an enormous quantity of water, metals, and organic compounds. This material had to go somewhere. 3 possibilities emerge. Local construction. The materials were used to build structures within the outer solar system. Massive space stations, habitat rings, or even artificial worlds could have been constructed using Kuiper Belt resources. These structures would need to be hidden, either by distance, stealth technology, or location in regions we haven't surveyed thoroughly. Dr. Torres noted, the outer solar system is vast. Our surveys have cataloged only a tiny fraction of what's out there. A structure even as large as Ceres could hide in unexplored regions, especially if designed to minimize reflection and thermal emissions. Transport to inner system. The refined materials were transported inward, possibly to Mars' orbit, the asteroid belt, or even Earth's vicinity. This seems logistically challenging, but not impossible. Von Neumann probes, self-replicating machines, could establish transportation networks spanning the solar system, moving materials efficiently over vast distances. If something was building infrastructure in the inner solar system 50,000 years ago, the evidence might still exist, Dr. Chen noted. We should be looking for anomalous objects in stable Earth or Mars orbits, artifacts that don't match natural celestial bodies. Export from solar system. The most unsettling possibility is that materials were transported out of the solar system entirely. If the harvesters represent an interstellar civilization mining resources from multiple star systems, the extracted materials could be en route to colonies, manufacturing centers, or megastructures light years away. The timescales make this plausible, Dr. Malhotra explained. If extraction occurred 50,000 years ago and the destination is 50 light-years distant, The cargo would be arriving at its destination right about now. The miners could have moved on to other star systems long ago, but their harvest is still traveling through interstellar space. This scenario implies that our solar system isn't isolated. It's part of a network of resource extraction sites operated by civilizations with technology and timescales we can barely comprehend. Several researchers have detected what might be warning beacons at the gap boundaries, low-power radio transmissions that pulse at regular intervals, seemingly marking the edges of the extraction zone. Dr. Vasquez discovered the signals using the Very Large Array in New Mexico. We detected weak radio emissions at 1.42 GHz, the hydrogen line, one of the most fundamental frequencies in the universe. The emissions pulse every 47 minutes, remarkably regular, and they originate from multiple points along the gap's inner boundary. The 47-minute period is significant. It doesn't match any natural rotational or orbital period in the region, but it does match the time required for light to travel across the gap's 4 AU width, suggesting the signals might be coordinated by a central control system using light-speed communication. It's like buoys marking a shipping lane, Dr. Vasquez explained. The signals say, "Extraction zone, stay clear." Any object approaching the boundary would receive these warnings with increasing frequency and intensity. The signals carry more than just timing information. Detailed analysis reveals modulation patterns suggesting data encoding, possibly identification codes, operational status updates, or instructions for automated systems. We can't decode the content, Dr. Vasquez admitted. The encoding scheme is completely unknown, but the structure clearly indicates information transmission, not random noise. Most disturbing, the signals show no degradation over the years they've been monitored. The power levels remain constant, the timing stays precise, and the modulation patterns don't drift. These beacons have been operating for a minimum 50,000 years, and possibly far longer, maintained by systems that never fail and never run out of power. Are there other gaps in the solar system? If the Kuiper Belt depletion represents mining operations, we might expect to find similar evidence elsewhere. Dr. Chen expanded her survey to other regions. I looked at the asteroid belt, the scattered disk beyond the Kuiper Belt, and even the distribution of Oort cloud objects based on long-period comet orbits. What I found was disturbing. There are anomalies everywhere once you know what to look for. The asteroid belt shows a depletion zone between 2.8 and 2.9 AU, the so-called Kirkwood gaps, traditionally explained by resonances with Jupiter. But one gap is wider and more pronounced than Jupiter's gravitational influence should produce. The gap at 2.42 AU is suspicious, Dr. Chen reported. It's too clean, too empty, and like the Kuiper Belt gap, it shows spectroscopic evidence of processed materials, metal fragments with compositions suggesting refining rather than natural differentiation. Even more intriguing, size-frequency distributions in different asteroid belt regions suggest that objects in certain size ranges have been preferentially removed. Natural collisional processes should produce a smooth distribution of sizes, but several regions show depletions of objects in the 50 to 200 kilometer range, exactly the size that would be most valuable for mining operations. It's as if someone came through the asteroid belt and cherry-picked the most useful objects, Dr. Torres noted, left the small debris alone, ignored the largest bodies that would be hard to process, but systematically harvested everything in the sweet spot for industrial applications. The Oort cloud shows similar anomalies. Analysis of long-period comet orbits suggests certain regions of the distant Oort cloud are depleted compared to models. The depletions form patterns, not random voids, but organized gaps that could represent systematic extraction. If these patterns are real, and the evidence is still preliminary, then we're looking at mining operations on an almost incomprehensible scale, Dr. Webb said. Not just one gap in the Kuiper Belt, but multiple extraction zones throughout the entire solar system. It would mean our solar system has been an active mining site for thousands or millions of years. At the edge of our solar system, in the frozen darkness beyond Neptune, 10,000 objects are missing. They should be there, preserved since the solar system's formation, but they're not. In their place lies a precisely defined void, with boundaries too sharp to be natural and chemical signatures suggesting industrial-scale processing. The evidence points to a conclusion that seems impossible, yet fits the data better than any alternative. Something has been mining the Kuiper Belt. The operation spanned thousands of years, extracted massive quantities of material, and employed technology so advanced it leaves almost no direct evidence. Only the absence where present should be, and subtle chemical traces of industrial processes we can barely detect. Whoever or whatever conducted these operations possessed capabilities that dwarf human achievements. They could capture and process 100-kilometer ice bodies. They could sustain industrial operations across thousands of years without visible infrastructure or obvious power sources. They could delineate precise operational boundaries and enforce them with systems that still function 50,000 years later. And most disturbing, the evidence suggests they haven't left. The gap is expanding, slowly but measurably. The warning beacons still pulse. The trajectory anomalies still steer objects away from the extraction zone. The mining continues, just at a slower pace than during the initial harvest. Why would an advanced civilization mine our Kuiper Belt? The answer might be simple resources: water for life support and fuel, metals for construction, organic compounds for manufacturing. The Kuiper Belt contains all of these in abundance, conveniently located in cold storage at the edge of a planetary system. Or the answer might be more complex. Perhaps mining serves as cover for other activities, observation, research, or even social studies of developing civilizations. By establishing a presence in the outer system, these entities could monitor Earth from a safe distance, watching human development while extracting resources to support their infrastructure. The timeline suggests they've been here since before human civilization. They watched as our ancestors domesticated fire, invented agriculture, built the first cities. They were here when the pyramids were raised, when Rome fell, when Columbus sailed, and they're here now, still operating in the darkness beyond Neptune, still harvesting the raw materials of the solar system for purposes we can only imagine. The Kuiper Belt gap forces us to confront a reality that many would rather avoid. We are not alone in the solar system. We never have been. The question isn't whether other intelligences exist, but how long they've been here, what they're doing, and whether they're aware of us. The missing 10,000 objects tell a story written in absence, in empty space where fullness should be, in chemical traces of industry conducted in the cold beyond worlds. It's a story of intelligence operating on time scales and scales we're only beginning to comprehend. And it's a story that's still being written as the gap slowly expands and the ancient harvesting continues. Somewhere in the darkness beyond Neptune, machines still work. Systems installed millennia ago still function. The boundary beacons still pulse their warnings into the void. And slowly, inexorably, more of the Kuiper Belt vanishes into the gap, processed and extracted by entities we've never seen, but whose presence we can no longer deny. The solar system is not the pristine, empty place we thought it was. It's an industrial site, a resource extraction zone, a place where intelligence has been operating far longer than humanity has existed. And we're just now beginning to notice the signs. What else are we missing? What other evidence of ancient operations hides in plain sight, disguised as natural phenomena because we lack the context to recognize artificial structures? The gap in the Kuiper Belt might be only the most obvious example of a truth that pervades our solar system. We are not the first, not the only, and quite possibly not even the primary intelligence operating in this small corner of space. The void between 48 and 52 AU tells us that the cosmos is stranger, more populated, and more industrially active than we ever imagined. The question now is not whether we're alone, but whether we're ready to acknowledge that we never were.